In the last video, we have learned how to draw Lewis structures for elements, ions, and ionic compounds. And in this video, we're going to continue to draw Lewis structures, but now for molecules and polyatomic compounds in which they have covalent bonds, meaning that it involves electron sharing. And we're going to go over some fundamentals before we start drawing the Lewis structures. And first of all, as a reminder, covalent bonds involve the sharing rather than fully transferring electrons, as in ionic compounds, to achieve an octet. Now, before we start, we need to go over some terminology. So first of all, let's start with the bonding pair. So a bonding pair is or consists of two electrons shared between two atoms, okay? And usually the bonding pairs are represented by lines. Okay, so for example, in this structure right here, which represents the Lewis structures of H2O, so the lines right here are the bonding pairs. So these are the bonding pairs, which represents the two electrons. And then we have non-bonding pairs, also known as lone pairs. And these are two electrons that are only on one atom. So in this case, you can see them. The lone pairs are here over the oxygens, okay? And they are represented by dots. So these are the lone pairs. Now, in addition to bonding pairs being a single bond, some atoms, to complete their octet, need to share more than one electron pair to get their octets. Okay, now note that right here, we're not going to discuss the exceptions to octet rule. We're going to discuss them in a different video, but just to show you a few examples, and if two atoms share two electron pairs, these usually are represented by double bonds. Okay, so for example, in carbon dioxide, we have here two electrons. Let me highlight it for you. Two electron pairs, and these represent the two double bonds. And sometimes they share even three electron pairs, as in nitrogen. So we see these three electron pairs right here. Let me highlight them for you, and these become a triple bond. Now, if you have a polyatomic ion, how can we draw a polyatomic ion? So remember, a polyatomic ion consists of atoms bonded together via covalent bonds, and the whole thing, or the whole polyatomic ion, has a charge. So we're going to use a combination of these rules, meaning that we will utilize the rules for drawing a Lewis structure as we're going to do with any covalent compound, and then we're going to put the structure between brackets and then assign the charge as a superscript, as indicated here. So for example, this is the nitrate ion. Okay, and remember, very early on in the semester, you were required to memorize the list of polyatomic ions and their charges, and this comes in handy right now to know these rules, okay? Because sometimes it will give you nitrite, or I can just say, no, sorry, not nitrite, it's nitrate ion. I misspoke, so this is a nitrate ion. All right, let's break up this with a question, and I want us to identify from this practice problem how many bonding, okay, means that the lines and non-bonding or lone pairs are available. So simply we're going to count. So for the bonds, I have here 1, 2, 3, 4, 5, and 6. So bonding is 6. And then we're going to count the lone pairs. I'm going to highlight them. 2, 1, 2, 3, 4, 5, and 6. Let me also count them. 1, 2, 3, 4, 5, and 6. So 6 non-bonding. Now let's continue with how now to draw a Lewis dot structure, and we will add on to the terminology. In addition to the bonding and non-bonding pairs, we need to know what is meant by a skeletal structure. So a skeletal structure includes all the atoms that are arranged in the order which they are bonded to each other. And then we have a central atom, okay, which is an atom bonded to two or more atoms. And I'll be using that when I'm drawing the Lewis structures. And then a terminal atom simply is an atom bonded only to one other atom. All right. So I thought it would be best for us to use an example to walk you through the steps of how you're interested. You're not required to know the name. This is called a formate item. And I'm going to walk you through the steps one by one. All right. The first step, and this is, by the way, a polyatomic ion, because I thought I would include the example of something that includes covalent compound and a charge. First step is we're going to calculate the total number of electrons by adding the valence electrons together. Okay. So, and these have rules. So valence electrons for any main group element is equal to the group number in the periodic table, which you already know from the last video. Now, for polyatomic ions, which is the example that we have, we can either add an electron for a negative charge or subtract an electron for a positive charge. So let's see how we're going to do this. So hydrogen right here is in group 1. So let's count. It's 1 valence electron. Okay, or let me just do this. So I would say hydrogen, or number of valence electrons, is the hydrogen plus the carbon plus 2 times the oxygen plus 1 electron. Okay, and I'm going to say 1 because hydrogen is in group 1, and then 4 for carbon, and then 2 times 6 because oxygen is in group 6, plus the 1 electron. So we have here 12 plus 4 is 16, 17, 18. So we have a total of 18 valence electrons. Okay. Now, next step is we gonna identify the central and terminal atoms. So how can I now decide which is gonna be my central atom and which side is gonna be my terminal atom? So the more electronegative elements are gonna be in the terminal position, okay? And the less electronegative element is going to be in the central position. And let's think about why, conceptually, why that might be the reason. So a more electronegative element will not have the tendency, compared to a less electronegative element, to donate its electrons. So for example, if we're talking about carbon, so if we have in CH2O minus, okay, or how did I write it? Let's look at the other slide. It's HCO2 minus, HCO2 minus, right? We are between, okay, so first of all, hydrogen has 1 electron only, so it can only form 1 bond. So, and I'll talk about that in a second. Now it's between carbon and oxygen. So let's look, this is my second period, so carbon, nitrogen, oxygen, and electronegativity increases from left to right across the period. So in this case, carbon is going to be my central atom. So carbon, we can say, is central. Okay, I'm going to draw it in the center. Okay, and then I'm going to have oxygens as terminal. Now note, hydrogens are always going to be terminal, as we discussed a second ago, because it only has one electron and can form only one bond. Okay, and H, we can also draw it as C, H, O, O. I don't think it matters. Okay, and so this is the arrangement. Now what we're going to do with this arrangement, let me copy and paste it and go to the other slide. And now I'm going to draw out the skeletal structure by adding single bonds. And for each single bond I'm adding, I'll be subtracting 2 electrons for each bond. So we're really keeping account. So I started out with 18 electrons, and I'm going to add now 1 single bond, which is 2 electrons, another single bond, 2 electrons, and the last single bond. So I added 1, 2, 3. So 3 minus 3 times 2, which is 6. So I'm left over with 12 electrons. Okay? All right. Now, before assigning any other type of bonds like double or triple bonds, I must complete the octet of the terminal, okay, of the terminal atoms using the, and also the central atom if it applies to it, using the remaining valence electrons. Okay, so we have, okay, so we want to complete the octet for oxygen. So I'm going to add 1, 2, 3, 4, 5, 6, and the 7, 8 come from the single bond. Okay, 1, 2, 3, 4, 5, 6. Okay, so I have here 2, 4, 6, 8, 10, 12. Okay, now I have distributed all the valence electrons. So now minus 12 electrons that went to the oxygen. So I have 0 valence electrons left. Okay. Now, how, if we note right here, carbon has only 6 electrons. Okay, I forgot, by the way, to add the brackets and the negative charge for the ion, okay, because it's a polyatomic ion. Now, how can I complete the octet for the carbon? Because it's missing 1. So in this case, if it lacks an octet, any atom can donate its lone pair of electrons. So let's go back right here and copy this to the next slide. Okay, and paste it. So we know that the oxygens have a pair of electron to donate right here. So what's going to happen is it's going to give, and I'm showing here in the arrow that is going to form a single bond, okay, from this lone pair. So the new structure right now is going to be CH double bond O, and here A, and then here the polyatomic ion. Okay, now after you're done, you need to double check if you have the same number of valence electrons that you started with. So let's count them. So we hypothetically now should get 18 valence electrons. So I have here 2, 4, 6, 8, 10, 12, 14, 16, and then 18. So yes, I have 18 valence electrons. And this is an amazing way to see that if you have drawn the Lewis structure correctly or not. All right, now let's work on a problem together to just emphasize this concept. So this is very similar. This is also a polyatomic ion, and here I broke it down for you since we are just learning this. So let's start with counting how many valence electrons. I have carbon plus 3 times oxygen plus 2 electrons. So I have here carbon is in group 4 plus 3 times 6 because the oxygen is in group 6 plus 2 electrons. So I have here 24 electrons, valence electrons. Now, what is the central atom? Very similar to the last slide. The central atom has to be the less electronegative. So it's going to be carbon compared to oxygen. So here I can say carbon. How many bonding pairs are present? Now we need to draw the Lewis structure to determine the last 2 bullet points. So in this case, I can say here it's COOO. And then I'm going to add 3 bonds. 1, 2, and then here is 3. Okay, and since this is carbonate and polyatomic, I'm going to add a 2 minus. So in this case, 1, 2, 3. So we have here 6. So 24 minus 6 is 18. So minus 6 electrons will be 18 left. And then I will complete the octet of the oxygen. 2, 4, 6, 8, 10, 12, 14, 16, and 18. So minus 18. So I have 0 valence electrons. And very similar to the example that we did before, one of the lone pairs from one of the oxygens is going to be used to complete the octet of the carbon. Therefore, my new Lewis structure is going to look something like this. Okay. And now let's count our electrons and make sure that it's 24. So I have here 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and then 24. Okay, now I want you to pause the video and attempt to do this problem on your own. This is a little bit different than the one that we did before, but it should be simple. And I'm going to start by counting the valence electrons. So valence electrons right here are going to be 2 times carbon plus 2 times nitrogen. And this is equal to 2 times 4 because carbon's in group 4. And then nitrogen is in group 5, so 2 times 5. And this should give me a total of 18 electrons. Now, central atom, nitrogen, is one of our 3 most electronegative atoms. Nitrogen, oxygen, and fluorine are our 3 most electronegative. So naturally, nitrogen is going to be terminal and carbon is going to be central. How many bonding pairs? Now we need to draw the Lewis structure. So I'm going to start by C and C. And here N and N is going to be terminal. And then, so we added here 1, 2, 3. So minus 3 times 2, which is 6. So we have 12 valence electrons. And then I'm going to complete the octet of the nitrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so minus 12 valence electrons, so 0. Now note that we have now 2 carbons that we need to complete their octet. So in this case, what's going to happen is each nitrogen is going to donate 2 lone pairs to form bonds. So in this case, it becomes the structure. All right, so it becomes triple bond. I want to just make sure that now every nitrogen has only 1 lone pair. And let's double check how many electrons do we have? And just, let's see if we're going to end up with 18. So 2, 4, 6, 8, 10, 12, 14, 16, and then 18. So yes. So how many bonding? Oh, I forgot to write how many bonding pairs in the two questions. So how many bonding pairs are in this question? So they're going to be 7. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, and how many lone pairs? We're going to have 2 lone pairs. And in the past question, let's count how many bonding pairs. I have 1, 2, 3, 4. And then how many lone pairs? We're going to have 1, 2, 3, 4, 5, 6, 7, 8. 8 lone pairs.